this program here on death, a topic that is probably the least comfortably talked about topic in our society. I mean, we're far more comfortable talking about sex, I think, than actually talking about death in a deep, intimate, real way. It's particularly poignant for me right now that there's a friend and colleague of ours in the science, religion, sustainability movement, Jack Heckelman, who right now today is being cremated. And so it's kind of thinking about death is really on consciousness for me now. One thing important to say from the outset of this is when Michael and I are working on this program has nothing to do at all with our different beliefs about what happens to soul, spirit, consciousness after death. It has nothing to do with that. It's simply dealing with the material fact of death at all levels of reality. And then what that means for our own understanding of our own death and those of our intimates. So to begin, I actually have an unusual format for this, and that is my friend Jack Heckelman, who died this past Sunday. When he was entering hospice 6 weeks ago, he was 81 years old, when he was entering the hospice program 6 weeks ago, I was inspired to write a song called Death Has Lifted Us. And I've designed my program here. You see 5 parts here, 5 different kind of groupings of natural sciences. The small print here is not designed for you to see. It's kind of a crimp for me so that I don't have to use a script. But just the basic categories here are 5. There are 5 verses to this song dealing with each of these concepts. So I'm going to be singing my way through this program, kind of a little unusual for a science writer, and any who wish, I'll give you an opportunity as well to do a sing-along at the end after we've got through all the verses. So let us begin. Death with Deep Time Eyes. First verse of Death Has Lifted Us. And the tune I'm using, I think it's hymn number 207 in the UU hymnal. It's traditional hymn melody Hyfridol. Anyway, you might recognize it as I go along. Full of life at this keen moment, universe in human guise. This first part here, I'm sure this is something that Michael talked about on Sunday, and that part of this understanding that the sciences bring us of the universe and who we are in the universe is that we're not just separate beings, human beings, studying the universe out there, but we are expressions of the universe, just like we are expressions of Earth. We grew out of the dynamics of the Earth processes. We grew out of the dynamics of the universe processes. We are no less an expression of the universe than stars and galaxies, though we are quite a bit smaller. But this understanding that here we are, all of us sitting in this room, full of life at this keen moment, we are, each of us, the universe in human guise. Species swam and crawled before us, salty seas still spill from our eyes. All right, this brings us into the first sciences here of paleontology and evolutionary biology. And just a quick walkthrough of what we in Western science, which has now become a global effort. It certainly started out in Europe, but the sciences now are a global effort being conducted and contributed to by people of all ethnicities, all cultural and religious backgrounds throughout the world. 1796, Georges Cuvier, the great French anatomist, was studying the teeth of what we now call mastodons and mammoths, kinds of elephants that are extinct, studying the teeth and comparing them with African and Indian elephants, the only kind of elephants that are still alive. And he said, you know what? These teeth are so distinct. And our explorers have studied so many of the continents that I now can say that this animal that we call mammoth is no longer in existence. It's extinct. And this may seem amazing to those of us who are very familiar with extinction as sort of a current topic, that there was a time Prior to 1796, none of the Western scientists and intellectuals accepted that anything had ever gone extinct. No species had ever gone extinct. So Georges Cuvier pronounced that these teeth and tusks that we call mammoths and mastodons are of extinct creatures. Radical concept. Radical concept. Now, 1796, this was around the time that Thomas Jefferson was very active here in the United States, both in politics, government, and as a great American naturalist. He had actually studied fossils of giant ground sloths, and there was a sloth, Jefferson's ground sloth, named after him. Well, we Unitarians will claim him, some of us claim him, Thomas Jefferson, as one of our own. He doesn't talk about God, he talks about nature, but listen to this. His sensibilities of how the universe is in balance and how it operates were so offended by Georges Cuvier saying that something had gone extinct that here was his response. Actually, I'll put it over here. Thomas Jefferson wrote in his notes in the state of Virginia, actually this was a few years before Cuvier's official announcement, but he said, Thomas Jefferson wrote, "It may be asked why I insert the mammoth," here's the mammoth here, here's a mastodon, "into my list of American mammals as if it still existed. I ask in return, why should I omit it? Such is the economy of nature that no instance can be produced of her having permitted any one race of her animals to become extinct, of her having formed any link in her great work so weak as to be broken." Again, this is before evolution, 1796, before 1859, Charles Darwin, Origin of Species. And so the thinking then was the great chain of being. Everything was in balance. God may be in or out of the picture, but whether it was God or nature, everything was perfect as is. Well, you know what Thomas Jefferson did to try to prove Georges Cuvier wrong? Got Congress to approve the Lewis and Clark expedition. He was going to have Meriwether Lewis keep an eye out for finding a mammoth out in the unexplored territory of the West. I mean, we're all read in our history books that it was to find a passage through, a water passage through the Pacific Northwest. But the great naturalist wanted to prove Cuvier wrong. So here we have the beginnings of an understanding of the role that death has played as being natural. Now we move into the role that death has played in being generative, that is creative. Moving to 1859, we have Charles Darwin and Alfred Russel Wallace. Darwin, of course, 1859, Origin of Species. Darwin could not have come up with the theory of evolution by natural selection had there not already existed the concept of extinction. This is so important. Loren Eiseley. Any of you read any of Loren Eiseley's books? I just took his books out with me on a solo camping trip in the Gila Wilderness. Firmament of Time. Loren Eiseley talks about how before the complexity of life, that is evolution, could become natural as opposed to created by fiat, by a deity, before it could become natural, death had to become natural. So before life, complex life could become natural, death had to become natural. Extinction had to become natural. That's the basis of Cuvier in there. So with Charles Darwin, we have the understanding that without death of species, there could be no complexification of life. Life here on Earth would still all be slime. So truly, death has lifted us, death of other species in the process of natural selection. The amazing thing is Darwin knew of extinction, but he did not know of mass extinction. Mass extinction was not really entertained as a possibility by paleontologists until the 1930s. And it took another couple decades for it to become the majority view. That is, there was a sense of Earth isn't going to get things that wrong. Extinction's fine because as one species goes out, another species comes in, right? There's always a balance still in nature. Extinction could be accepted, but mass extinction? This was scary stuff. Very recent understanding. Then, of course, in 1980, Luis Alvarez was the one who made the big discovery that the dinosaurs died off not because of climate change, but because of a meteor impact. So here we had the sense that the universe from outside of Earth could send something here that would disrupt life and cause a mass extinction. That was the 5th major mass extinction. 1966, the Overkill Hypothesis. Have any of you heard of the Overkill Hypothesis for why mammoths and mastodons went extinct? Do you know that that was invented in 1966 by Paul Martin, who lives here in Tucson, emeritus, University of Arizona? He's my friend and colleague. He and I just published a paper together, and we're staying at his weekend home.
He was in church here on Sunday.
He was in church on Sunday, yeah, Paul Martin. Great Pleistocene ecologist, all right? I learned how to look at nature with deep time eyes by studying with Paul Martin. Okay, so in 1966, here's where humans get involved, okay? You think about one thing about, okay, here's some meteors coming in. Here's where Earth, via the human, is causing problems. Now, in 1966, Paul Martin basically said mammoths and mastodons went out when the first peoples came into the Americas who could kill at a distance, and that our animals had not co-evolved with it. And have you been to the Galapagos Islands? You've probably heard the tameness, that you can walk right by, you know, seals and other creatures there. Same thing here in North America. And then the large creatures, of course, can't reproduce fast enough to keep up with it. Not just North America, but the moas in New Zealand, the elephant birds in Madagascar, many of the animals in Australia. When the Polynesians first arrived in Hawaii 1,500 years ago, flightless birds went out. Wherever humans first arrive at which they have not co-evolved with the large animals, the animals go extinct. This is not a mass extinction yet. It's what Paul Martin calls it extinction of the massive. Get the distinction? It's the large critters that go out. So here we have an understanding of the human role in this. In the 1970s was when Norman Myers, Edward O. Wilson, and others first alerted us to the sense that, hey, we're in the midst of the 6th major mass extinction, that there have been 5 mass extinctions, major mass extinctions, since complex life developed. The dinosaurs was the 5th, and now we're in the midst of the 6th through our own cause. So, we understand through paleontology and evolutionary biology that death is natural. Some forms of species death have absolutely been creative, wouldn't have complex life without it. And certainly without the death of the dinosaurs, the mass extinction of the dinosaurs, I would be a dinosaur standing here talking to you right now, and you'd all be dinosaurs. The mammals probably wouldn't have had a chance to take off. So, here we have the sciences. Moving on with our song. Species swam and crawled before us, salty seas still spill from our eyes. Get that? We understand that because of our evolutionary heritage, not only have there been animals before us, but there's a whole lineage that's our ancestors. And at one time, our great-great-great-great-great-great-grandparents lived in the ocean. Any of you reading Richard Dawkins' Ancestor's Tale? Yeah, I'm reading that now. He talks about how many great-great-great-great-greats it back. It goes through about 40 different sets of ancestors. So a great understanding that expands our sense of who our ancestors are, that our ancestors once lived in salty seas, and we still cry those tears. Death has lifted us, death has gifted us, yield we now our poignant ascent. May we shape memories in those who follow us, and bequeath them a planet blessed. Let's move on to verse 2. Verse 2, we'll move into embryology, cell biology, and a bit of ecology. Once mere zygote fetal fistful, spheres bewease on cellular death. As we elder, we shan't be wistful, fearful for our very last breath. All right, zygotes. We all know that when egg and sperm come together, fertilized, what you get is a zygote, a single cell that then doubles and doubles and doubles and doubles. And it's the reason that that doubling and doubling and doubling doesn't turn into a gigantic sphere is because along the way, some of the cells not only stop reproducing, but die. So it's the differential death of cells in zygotes and fetuses that give us shape. I had a sister-in-law once whose left hand was born malformed because the cells had not died between the fingers. That's what happens when cells don't know when to die. We also have in cell biology, so it was in the 1800s, we're studying chick embryos and so forth. This was discovered. 1972, Andrew Wiley discovered what is now called programmed cell death. And the amazing thing about programmed cell death is the understanding that it's not just in fetal development, but as mature human adults, cell death is an absolute necessity, and these cells are basically programmed. You must die, and you must die now. And if cells rebel against dying when they must, it's called cancer, right? Year 2000, an amazing understanding. You know, we've always known that the fetuses have more neurons than we have, and that we're like losing our neurons as we age. The amazing thing is that they discovered that, yes, it is that we lose half by the time we mature. But the loss of the neurons, the death of the neurons, allows the possibility for more connectivity, the synapses. And the wisdom, the intelligence, the creativity, the putting concepts together comes from having the connections, not the sheer mass of numbers of neurons. So here we learn too, in terms of creative intelligence, death of cells is an important part. Death has molded us. Death unfolds through us in every morsel of food we partake. Well, everyone, we didn't need science to know this, has an understanding of food webs. All cultures have, and in fact, our culture is probably the most deprived in having an understanding that every time we eat, we're killing. It's death that's happening, that we're not actively involved in the death process anymore. So the very gift of food relies on death. Passing the torch to the new generations, final gifts that we all shall make. Move on to verse 3, and the next sciences we're coming to are astronomy and astrophysics. All right, verse 3. Starry heavens no more immortal, praise celestial finitude. Praise celestial finitude. Starry heavens no more immortal. Well, that's obvious to us, right? It wasn't obvious long ago. There was a sense, in fact, we can think about it now. This time of year, we're seeing as the sun sets, after the sun sets, Orion, the winter constellation, is very low in the southwest. Scorpio, the summer constellation, is in the southeast. Those constellations were named more than 2,000 years ago. And guess what? They haven't changed. Truly, the heavens are immortal, right? All peoples have felt that. The heavens are immortal. Then, you know what happened? 1572, during the time when the great astronomer Tycho Brahe was alive, and then again in 1604, when Johannes Kepler was alive and active, we had starbursts. We now call them supernova explosions. We know that they mean death. But in those times, all they saw was the sky light up with a new star, looked like birth of stars, that had not been there before. Now, here was the frightening part for them. The cosmology at that point basically said that anything from the moon closer to the Earth, between the moon and the Earth, is not immortal. You can have birth and death and all kinds of things happening. That's not, the divine isn't really there. Beyond the moon, the stars beyond the moon, that's where immortality lies. Well, they took a parallax of the supernova. You know, kind of like we have binocular vision, that if you have the distance there, you can see and you can triangulate. And they said, oh my gosh, these starbursts happened well beyond the distance of the moon. The heavens are not immortal. This was a great blow to cosmology of the understanding of where you find God, where you find perfection, and where you find the fallen? Here we have it. 1572 and 1604, these were supernova explosions, and guess what? There hasn't been one since that's been visible in the northern hemisphere to the naked eye. Should be about one a century in our Milky Way galaxy, so we're a little overdue. Next step in understanding the role of death as being natural, and in this case, generative, highly generative. 1938, Hans Bethe, the great astronomer, Bethe was the great astronomer, was the first to be able to discern what it was that was powering the sun. It was hydrogen, the most simple element, hydrogen, fusing into helium. In the beginning were great clouds of hydrogen gas up at the top here. And we've now learned that four nuclei of hydrogen fuse into a nuclei of helium. And the energy released, the mass that turns into energy, is what powers our sun. This was discerned in 1938. And so at that point, calculations could start to be made about how much hydrogen is in the sun, how much is being burned into helium, and therefore, how much longer we have for the sun to live. It was at this point that the understanding came that at some point our sun would die. Now that point is a long time on. Our sun has been burning for 5 billion years since the beginning of the solar system, and it's got another 5 billion years to go, all right? So we really don't have to worry about that. But it was a concept of death happening. The next major step happened in 1957 when I was going into kindergarten. The great astronomer, astrophysicist Fred Hoyle and colleagues discovered one of the most amazing things that science has ever taught anyone. And you know what? Our schools don't teach it yet. It's mainstream science. And what it is simply this: we are made of stardust. Every single atom in our body, other than the hydrogen in the H2O in the water, every single atom of calcium in our bones, iron in our blood, carbon in our cells, nitrogen in our muscles, potassium and phosphorus in our brains, every single atom was forged inside a giant star that lived and died and recycled its creations back to the cosmos before our sun was born. This was only known in 1957. There are still PhD chemists coming out of their chemistry program and not learning where the chemical elements came from because it kind of falls between physics and chemistry. But we truly are stardust. And this is when I go into a children's RE program and I've given one opportunity to teach science, it's always the concept of we are made of stardust. And that stars die, and thank goodness they did, because without the death of stars, there would be no planets and no life, right? First generations of stars that lit up at the beginning of the universe, scientists call the Big Bang, 14 billion years ago, we call the Great Radiance. None of those stars could have rocky planets around them, only big gas balls, because there was only hydrogen and helium then. Again, this is what science has discovered. This is where science is helping us discern that death is not only natural, but thank goodness it exists at all levels of reality, that there is death in the heavens. Finally, in about 1998, there had always been an understanding that galaxies collide. Here's a picture of galaxies colliding here. Here's another picture, galaxies in collision. Look at this one. Isn't that amazing? Thanks to the Hubble's telescope that we have these beautiful pictures now. These to me are religious icons. They truly are for me. But in 1998, there was a big stir that went on where calculations went on for, Andromeda is our closest neighbor galaxy. When we see Andromeda, it looks very similar to what we ourselves look like as the Milky Way. Andromeda and the Milky Way are very large galaxies that have formed out of these galactic collisions. The Milky Way has consumed other galaxies, which is why we're so large. And guess what? In about 2 to 3 billion years, Andromeda and the Milky Way are going to start dancing with one another. a kind of a collision. Now, the stars are so far apart that they'll move through each other, and it's not like the stars are going to mangle one another. But there's going to be such gravitational distress going on that a lot of new stars will form. So here we understand that even at the level of galaxies, galaxies are sometimes consumed by others. So continuing our song. Perished suns prepared the atoms, here in me and also in you. Death, divinity, wed eternally, God no longer divorced from this earth. See, as long as we thought that the heavens were immortal, where did our Western culture put God? Other cultures, not necessarily so. God was everywhere. Our earth-centered traditions that we brought back into our UU, just very much into our UU tradition. Of course, God, divinity was everywhere. God, goddess, whatever name you want to call, but divinity was everywhere, right here on earth. But our Western culture, God was where immortality was, up in the heavens. The heavens were different. We know that's not true anymore. God is no longer divorced from this earth. Man not by sin birth this fact of existence, nor by hubris shall e'er desert. I have a story for you. Exactly a year ago, Michael and I were in southeast Colorado. I mean, we've been all over the continent now for 3 years. And Michael was doing a program in a very conservative Catholic church in a very rural area of southeastern Colorado. And he was talking about the universe story and so forth, and there was a man in the audience who kept raising his hand and kept protesting and saying, how do you know that the dinosaurs went extinct before, humans were here? And I went up to Michael afterwards and I said, I understand biblical literalism to some extent, but I don't get why they can't just at least acknowledge that the dinosaurs went extinct before us. I mean, come on, can't they do that? Michael pointed me to a verse in the Bible, and here it is. Actually, there's more than one, but here's one that says it all. I never learned this. I grew up as a liberal congregational. Let me hold on to this so it can more easily be seen. This is in Romans chapter 5, verse 12. Wherefore, as by one man sin entered this world, and by sin death, so death passed upon all men. Do you get that? In our Western tradition, Paul, in the New Testament, interpreted the Genesis story such that before Adam sinned by disobeying God, there was no death. There was no death in the Garden of Eden. The way that our culture explains death, it's because of human error. All cultures have had explanations for death. All have. Ours is that it's through human error, human sin. We're responsible not only for the death of ourselves, but the death of the dinosaurs. There could be no death, nothing could die before Adam sinned. To me, this is amazing. This just shows what level of consciousness we have. I mean, what we have to deal with, what we're dragging along with us, unbeknownst to our conscious minds, that's just part ingrained within our culture. So, what do we get from deep time science in here? This whole understanding that man not by sin birth this fact of existence, nor by hubris shall e'er desert.
In other words, pride won't make us fall.
Right, well, pride, there are people now that are striving for using technology to attain immortality. You've heard of some of this. At least at this moment, no matter how much we think of ourselves and how self-important we are, this fact of bodily death is going to happen to all of us. Verse 4, we're moving into geology now, and this is rather a quick one here. Comfort taken in what we know of, mountains, lakes, ephemeral too. Cultures before our own. In fact, some of our even songs talk about the immortality of the mountains. This was discovered in 1787. James Hutton discovered that not only do mountains erode, but it's through the very erosion of mountains and the deposition of sediments that then new mountains rise and are made of sedimentary rock, the remains of previous mountains. This was new stuff. 1830, Charles Lyell published The Principles of Geology, 1830 to 1833 in 3 volumes, and this further cemented the understanding, made it very, very mainstream, that the science of geology is the understanding is that nothing is eternal here, not even mountains. In 1840, we had Louis Agassiz, a French anatomist, who actually was the first to understand that ice ages had occurred, and by that understood that there were places in France where he was living and in communication with his American colleagues and his British colleagues that had been covered with glacial ice, and not that long ago. And that why the reason we find so many lakes up in the Midwest area and the northern areas and not in the southern, in terms of natural lakes rather than dammed reservoirs, is because the glaciers carved them out and deposited the till, and that the lakes are ephemeral. The lakes go away too without another glaciation. So we are understanding that death is natural even in earth processes, and it's generative. It's the carving of the rocks by the glaciers that created the silts and the glacial loess that then blew and deposited in our prairie states and gave us such fertile soils for agriculture. Death is natural and generative. Finally, in the 1960s, this is a major one, plate tectonics. It had been presaged in 1930 by Alfred Wegener, continental drift we've heard of. But in the 1960s, there was tangible, irrefutable evidence that the continents were not immortal. And now we know, of course, that at one time what we call Africa, South America, North America, Australia, Europe, Asia, Antarctica, Greenland, all were gathered into a single supercontinent called Pangaea. And the breakup of Pangaea about 220 million years ago was what formed the Atlantic Ocean. That oceans were born. Ancient continents torn asunder, oceans born and soils renewed. Death the entrance fee, paid on exiting for all splendors and joys that arise. May there be love at our moment of passing, and a glimpse of the clear blue sky. 5th and final verse. We move now very simply into just basic geography and math. Were death banished from this fine planet, immortality would thus reign. No more death, but no more children. Finite landscape so would proclaim. 1505, exactly 500 years ago, Ferdinand Magellan circumnavigated the globe. And now there was absolutely no question that this earth was finite. And yes, Western Europeans could go out and conquer peoples in new lands and reproduce wildly in those lands, and so we could gain ourselves a little bit more opportunity. But all cultures have known, and particularly those who have lived in areas that are rich, fertile soils, such that you're bounded by other tribal cultures, you know that you cannot keep reproducing without having death, because you can't spread into your neighbor's tribal lands. I mean, you've got between this mountain, and that's it. All cultures have recognized. In fact, there's a Native American myth of one of the eastern Native American tribes. Here's the explanation for death. The humans were given an opportunity to have a choice. Either you can have death and no children, or you can have children and no death. What do you choose? It was the grandmothers that got together, the grandmothers that got in circle, and they chose to always have children, that there would always be children in our myths. There would always be birth, and to have birth, you need death. 1798, Thomas Malthus published his essay on population, which was an alert to the European cultures. Of course, we had been plagued with all kinds of wars and the bubonic plague and so forth, living in very unsanitary cities, so we weren't really pressed up with the understanding that there could come a time when population increase would be untenable. So here we learn that death is natural, and without the death of elders, we couldn't have a planet with children. Basic fact. There's nothing wrong with death of elders. Death in this new view helps us all to do, aging possessed of a fair dignity. Goslings in spring and ponds teeming with polyollywogs from now on through eternity.